Okay, in section 1.7, like I said, it should be pretty much a review for you guys. You've done perimeter, circumference, and area of all these different shapes before, so we'll blow through this pretty quick. Let's look at a square first. What's unique about a square? Dana? Oh, I thought you were raising your hand. Psyching me out. What's unique about a square? Roberts?
Always regular.
Always regular, meaning all sides and angles are congruent, right? So we have 90-degree angles, all sides are equal. So can somebody give me an expression for the perimeter of that figure? If you know a side length is S. So somebody tells you the side length is 5. How could you find the perimeter of it? Farley?
4S.
4S, yeah. If the side length was 5, you do 4 times 5. If the side length is S, we'll just take 4 times S. How about the area? Molinsky?
S squared.
Yeah, S times S, which is S squared. Very good. Okay. But what if we go a little more general and we go to a rectangle? Because a square is just a special type of rectangle. It's a rectangle with all sides equal, or all sides congruent. But in general, what's true about a rectangle? What are the characteristics of a rectangle? Tell me about the angles in a rectangle. They all have to be 90 degrees. They all have to be right angles. And then what's the other characteristic? Opposite sides have to be congruent. Yeah. Whereas in a square, all sides are congruent. With a rectangle, you just have to have opposite sides congruent. So in this particular example, they're calling the length, the longer side L, and the wide side width, or the short side width. Somebody give me an expression for the perimeter of that figure. If you were to walk around it and add everything up, Boyd, what would you get?
2L plus 2W.
Yeah, you've got 2 lengths and you've got 2 widths. There's a length on this side and a length on this side. That's where we get our 2 lengths. You got a width on bottom and a width on top. That's where we get the plus 2 widths. How about an expression for the area? Area of any box. Dana? What's that?
Well, like W times L.
W times L, or LW. Yep, length times width, or width times length. Order's not important with multiplication. Very good. Okay, let's jump down to our triangle. How would you find the perimeter of that triangle? It's got side lengths A, B, and C. And the height they call H. The height is just kind of an imaginary line from the pinnacle of the triangle drawn perpendicular to the base of the triangle. But if you wanted to find the perimeter, what would you do? If you were to walk around that thing, what would you get, Molinsky?
A plus B plus C.
Yeah, you just add it all up, A plus B plus C. And since we don't know any of the sides are congruent, we can't really give any fancy things like, oh, it's 4S or it's 2L plus 2W like we do with the other ones. We don't know if they're congruent or not, so we just have to say it's A plus B plus C. But how do you find the area of a triangle?
Base times height divided by 2.
Yeah, base times height, so B times H divided by 2. Anybody know another way to find it? That's equivalent to that? Maybe you've learned it a different way? Nicole?
1/2 times base times height.
1/2 times base times height. They're equivalent. Why? Well, because when you multiply something by a half, you're dividing it into 2 pieces. So those 2 things are equivalent there. How with a circle? Anybody, this might be way back from 6th grade, but remember the circumference? That's what we call the perimeter of a circle. The fancy word we have to walk around the circle, we call it the circumference. Anybody remember that formula? Yeah?
2 pi r.
2 pi r. Excellent. 2 pi r. 2 times pi times the radius. Okay. Does anybody know one other way? Let me give you a hint. Ignore the pi for a second. You have 2 times r. In a circle, what is 2 times the radius? Another word for? Cuff? Diameter. So really, if you took the 2 times the r, that would give you the diameter. So what would another formula for the circumference of a circle be? Pi times the Diameter, yeah, because really diameter is just 2 times the radius. So these two things are equivalent. How about the area formula for a circle?
Pi r squared.
You got it, Harmony. Pi r squared. Okay. Pi being the ratio of a circle's circumference to its diameter. I don't care if a circle's this big or if it's this big. If you were to take a string and wrap it around that circle and then divide it by the diameter, you will get the same number no matter what. What is that number? Approximately. Farley?
3.14.
Yeah. Pi. It's about 3.14. Doesn't matter how big the circle, that will be true no matter the size. If you take the distance around the circle, divide by across the circle, you're always going to get that 3.14 number. All right, so let's jump to example 1. It says find the perimeter area of the rectangle. Tennis. How many tennis players do we have in here? 1, 2? I thought you were a hockey player. Multifaceted. One swinging like this and one swinging like this. Get the full rotation.
Yes, Sam does too.
Yeah? The inbounds portion of a single tennis court is shown. Find its perimeter and area. Okay, so the nice thing is it's a rectangle. We can just plug and chug in our formula. So what's the length of our rectangle? Yep, I heard somebody say it, 78 feet. What's the width? 27. Really, would it matter if I mixed those two up? Would it matter if I called this width and this length? Doesn't matter. Okay, commutative property doesn't change anything. Associative property doesn't change anything. Okay, somebody crank it out for me. You better be able to beat me. 70, 40, 156, 54, 210? Is that what it comes out to be?
Yes.
Am I done? What am I missing? Label. Labels are extremely important. 210 feet. If you don't think labels are important, I think I've said it before, but that bridge they built in South St. Paul a couple years ago, they mislabeled like how much concrete to mix with some, I don't know, additional thing that made the concrete hard. They mislabeled it and they mixed it wrong, and they had to start the bridge all over. Okay, I wouldn't want to be the person responsible for that like $21 million mistake. I didn't label correctly. Yeah, it's coming out of your pocket. All right, how about area? Length times width, we'll take 78 times 27. Somebody help me out with that one. Don't sprain your finger. What'd you get, Roberts? 2,106. Now notice the difference is when we label things in area, 2,106 we say square feet. It doesn't mean we're squaring the 2,106. Square feet just means literally if you were to make little square foots in here, a foot by a foot, you would have 2,106 of them in this thing. Each of the things on the floor right here, each of these squares is 1 square foot. Okay, 1 square foot. All right, what do we got here? We're going to skip this one. We're going to skip checkpoint problem number. Let's jump to example 2. Fits in well. We just had the Olympics last summer. The smallest circle on an Olympic target in archery is 12 centimeters in diameter. Find the approximate circumference and area of the smallest circle. So somebody tell me, how could we do the circumference? Yeah, Roberts?
Pi d.
Pi d. They go a little different route. They want you to find the radius. So I suppose you could say if the diameter is 12, what's the radius? 6, right? So, oops, I'm sorry, half of 12, so it'd be 6 centimeters. So then your perimeter, if we plugged it into the formula, 2 times pi times r, you'd have 2 times, what are we using for pi? Yeah, we'll use 3.14, and the radius was 6. Or I like what Roberts said. Just do pi times diameter. I don't know why they made you break it down like this. So we could have just said 3.14 times 12. And what do you get there? 36 point... Nope, you're going to get more than that. 37 point what?
6, 8.
37 point what?
6, 8.
6'8"? What's your label going to be, Roberts?
Centimeters squared.
Yep, perimeter. Perimeter is a distance, so it's just going to be centimeters. When we get to our area measurement, we'll measure that in centimeters squared. Square centimeters, okay? What are we going to plug and chug for our area of the circle? Donnelly, what do you think?
3.14 times 6 squared.
Yep, radius was 6, so pi times radius squared, 3.14 times 6 squared. So you got 3.14 times 36. Somebody help me out. Hager, what do you got?
113.4.
On the nose?
Yep.
Okay.
04 actually.
Oh, 0.04? Okay. 0.04. And then what would your label be, Hager?
Centimeters squared.
Centimeters squared, or square centimeters. Yep. So it's literally how many little square, if you had a centimeter by a centimeter, how many of those little squares would fit inside this circle. Very good. Okay, we're going to skip this one. We're going to jump to this real quick. Triangle JKL has vertices 1, 6, 6, 6, and 3, 2. Find the perimeter. Okay, we'll take a second to quick plot those points. I'll do it up here as well. 1, 6. Remember, you got to go into the elevator before you go up or down. So in 1, up 6. In 6, 3, 4, 5, 6, up 6. And then we've got 3, 2. Get my line tool out. Now, one of those distance, we're finding the perimeter, so we're finding the walk around distance, correct? One of those is really easy to find. Which distance is really easy to find? The top one. God darn it, I can just count boxes. What's the distance on the top one? 5. That's not so bad. How are we going to find the distance between the other points? What do we got, Farley?
Oh, the distance formula.
Distance formula. Distance between 2 points. I can't just count boxes on these diagonal lines. Okay? Because JK is horizontal, use the, I think it's called the, I don't know. Really don't know what it is. I forget. But we know it's 5 units. That's the big thing. We don't have the name memorized, but we have the concept memorized. I'll figure it out sometime and let you know. Okay, so if we want to use the distance formula to find the distance on the other lines, how do we do that? Quick refresher on the distance formula. What if we wanted to find JL? This one right here. Got coordinates 1, 6, and L is 3, 2. So what would you plug and chug into the distance formula? Think of a right triangle. It's kind of how we explained it before. Think of this right triangle right here. Okay. Now, to find C, I need to know A and B. Well, what's A? What's this distance? 2. And we get that from taking x coordinate minus y, or x coordinate minus x coordinate. So we find the difference in the x's and we square it, so that's like a squared. Plus this distance, let's call this b. How are we going to find that distance? It's your difference of your y coordinates, so we take 2 minus 6 or 6 minus 2, it doesn't matter, because eventually when you square it, it all gets positive anyways. 2 minus 6 is negative 4. Negative 4 squared is 16. 6 minus 2 squared is also 16. So it doesn't really matter. We're going to get what? 4 plus 16 square root of 20? which is going to be about 4 point... Hager's all over it. What's the square root of 20?
4.47.
About 4.47. Okay, now let's find the distance on the other ones. Again, think of a right triangle. You need to find your a squared and your b squared. Okay, so difference in your x's. Let's see, this point here is 6, 6. Difference in x's, 6 minus 3. Difference in y's, 6 minus 2. This is going to give me 3 squared is 9. 6 minus 2, that's 4 squared. That's going to be 16. 9, 16, 20. Oh, that's nice. What's the square root of 25? Right on the nose, 5. So if we want the perimeter of the whole thing, we'll just add it up. We had one side length was 5. We had a 4.47. We had another 5. So we're looking at 14.47. How come they just labeled it units? Dana? We weren't given any distances. We weren't told centimeters or feet, anything like that, so we just call it units. Very good. Okay. Let's see, what do we have here? Let's jump to number 5. Okay, and this will be our last example for the day, I think. Yeah, we've done one like that. We don't need to do that. Yeah, let's just do this last example. It says the base of a triangle is 24 feet. Its area is 216 square feet. Find the height. So here we have to use a little algebra. We have to work backwards a little bit. How could we set up an expression to solve this, or an equation to solve this? Knowing that the area of a triangle is base times height divided by 2. What do you think, Malinsky?
24H.
24H over 2, because you know your base is 24 feet, right? So do we know the area?
What?
Do we know the area already?
Yeah.
Yep, so let's stick the 216 in for the area. And like Malinsky said, the base is 24. We're looking for the height. And we got to divide by 2. Okay, little algebra. Fence posting. Get that h by itself. What would your first step be? Lewis? Yeah, get rid of that divide by 2. Multiply both sides by 2. We're going to get, what, 432 equals 24h. Last step. Farley?
Could you just like do like 216 equals 12H?
Yep, that's another way to look at it. You could simplify this side of the expression right away and say, hey, I've got 24 hats and I divide it into 2 groups. I'd have 12 hats in each group. Yep, that's just another way of doing it. Either way we do this, we should end up with the same thing. What's 432 divided by 24?
18.
18 on the nose. And I bet if you took 216 divided by 12, you're going to get 18 there as well. Okay? All right, I think we're good to go.